Hi, Mick McQuaid here with iste782 Visual Analytics. I'd like to cover Chapter 5, or at least cover the highlights of Chapter 5 of our textbook, R for Data Science. This chapter is on exploratory data analysis, which is a very important and pervasive subject, and we're going to take kind of a slice of that subject here. And by the way, we're skipping chapter 4 of the textbook. You should read it. We're going to skip quite a few of the chapters as we go on. Okay, so this is about the process around visualization. So the phrase visual analytics was popularized by the book Illuminating the Path, which asserts that visual analytics needed to be a front-to-back, start-to-finish process, not just the pretty pictures which are the centerpiece. So here's an example of the pretty pictures that are the centerpiece. And this may be what you want, but you have to slog to achieve it. This is actually a bar chart wrapped around a center. It shows a tremendous amount of information in a very compact and, I think, attractive way. But it's not easy to come up with something like this. You have to think about quality and quantity. So you want to ask high-quality questions, but you can't just rely on inspiration or talent or special insights beyond what others might reveal. Instead, you have to ask a great quantity of questions to maximize your chances of finding out something valuable. I can't stress that enough. And many of the questions are variations on these questions. What kind of variation occurs within variables? What kind of covariation occurs between variables? These are sort of archetypes for other questions. You can often find variation in categorical variables with bar charts. So here's an example where we use ggplot and say data equals diamonds and use geom_bar to get a bar plot or bar chart. We can find variation in continuous variables with histograms. So here's ggplot, data equals diamonds, with geom histogram, mapping equals AES, that's aesthetics, X equals caret. And you have to set the bin width yourself. You can't rely on the default bin width. You can explore categorical and continuous together. So here we have a categorical variable depicted by color. Color equals cut over here. And we have as the x variable the caret weight. And frequency poly, like histogram, has to have the bin width set manually. You have to play around with different bin widths. And you can find out what the typical values are by varying the bin width. And it should be no surprise in the diamonds data set that quite a lot of the data occurs around 1 caret. Quite a lot of the data occurs around half a caret, 3/4 of, or 2/3 or whatever this is of a caret. That people use these kinds of measurements. This is probably 1/3 of a caret. People make more diamonds of those weights than of other weights because they want to sell them. Okay, and you can find unusual values by limiting the coordinates. So here we've created a window. This chart would be well, let's put it this way: these observations would be invisible if we didn't limit with this coord Cartesian. This is a way of creating a little window into a portion of the data. And we see that there are these strange outliers here. And these are diamonds with widths of 58.9 millimeters, which is ridiculous. That's, you know, an incredibly gigantic diamond. And if you use the command arrange diamonds descending Y, you'll see that these two diamonds have very small prices associated with them. So obviously they're not really, 58 and 31 millimeters wide. They're data entry errors. There are also a few with 0 width, and obviously a diamond isn't going to have a width of 0. So you can replace these with missing values and continue to, so anytime that, I'm using the mutate function here. If the data is less than, if the width is less than 3 millimeters or greater than 12 millimeters, replace it with NA. Otherwise, leave it as Y. That gives us another diamonds data set that you can use to extract more information. Here's a comparison of canceled flights to non-canceled flights. And we'll look at a graph of this briefly. And what you'll see, so we're going to mutate. Canceled is going to be, is NA departure time. Scheduled hour is the departure time divided by 100. Scheduled minute is the departure time modulus 100. So the scheduled departure time is scheduled hour plus the scheduled minutes divided by 60. So we then get scheduled departure times, and here's the mapping with a frequency frequency polygon, and this result is a problem. There's so much variability in the non-canceled flights that it totally dominates the canceled flights, and it's hard to see a pattern. We'll discuss the NYC flight data later. Not today, later, another day. We can explore the covariance of a continuous and categorical variable with a matrix of box plots. So we're using geom box plot here, and we're flipping it on its side so that we have a column of box plots instead of a row of box plots. So this is the miles per gallon data, highway miles per gallon data, and we see that there's more variability in the subcompact class than in the other classes. And also because we placed it on its side, the labels don't collide with each other, so it makes it easier to read. Okay, we can visualize two categorical variables at the same time with a tile. So this geom tile, it's easier if I just show you what it looks like. And the fill is n. So the fill is the number of diamonds of this kind. So the largest number is the lightest color. So you can envision this kind of like half of a mountain that you're looking down on, sort of cut off here. This is the mountain peak, and it trails off. This would be the lowest. This area here would be the lowest area. So there are the fewest diamonds of this kind. And you can imagine that this is what people want to sell. So this is what they cut, this is what they keep, this is what they put on the market. There are so many diamonds in this data set that what we've done here in a scatter plot, so we're using scatter plots to visualize two continuous variables. There are so many that we're making the transparency extreme. So this is, you can think of this as opacity as 1/100th. And this gives us a picture of where the data is concentrated. Each one of these very, very, very faint circles represents a diamond. You can see that they're mostly concentrated in the area below 1.5 carats. Now another approach that we can use to deal with the problem of overplotting is hex bins. and we'll be using these on another day also. So this just uses a hexagon to show each bin. We can treat one of the variables as if it were categorical, so we can create a box plot using continuous variables. And this actually shows some nuances of the relationship between price and caret. So price and caret are obviously related, but we're going to find that they're not caret isn't the only thing that determines price. Okay, so when you see patterns, you have to ask yourself these questions. Could this pattern be the result of random chance? How can you describe T relationship implied by the pattern? How strong is the relationship implied by the pattern? What other variables might affect the relationship? Does the relationship change within subgroups of the data? Oh, I see. I thought I had corrected this misspelling here, but apparently I neglected to. Can I correct it on the fly? Yes. Okay, so now it's as I expected. Okay, so here's an example of a relationship that's really obvious. A scatter plot of Old Faithful. This is a famous geyser, and it shows two clusters. So this is the time of the eruptions and the waiting time between eruptions, and you can very plainly see the two clusters here. This is, by the way, a built-in data set. We can use models to extract patterns from data, and what we hope when we come up with a model, so here's a model that explores the relationship of price and caret by taking the logs of both. And then we take that model and add the residuals. So we take a look at the, basically this plot is a plot of the residuals versus carets in the Diamonds 2 data set, and with an alpha channel of 1/50th. So this is going to be very, very transparent, so we can see a lot of the observations despite overplotting. And what we see is a very clear pattern, and that's not what we want to see. What we would like is for our model to explain the variability that caret causes the variability in price. And what we're seeing from this is that caret is not the only thing that predicts price. We need a better model. We need a more sophisticated model. And by the way, you can abbreviate these ggplot calls, so you need to be able to do a lot of ggplot calls when you're doing exploratory data analysis. And so it's important to know that the parameters are positional by default. So if you omit data here, faithful is assumed to be the data as long as it's in this first position. If you omit mapping here, the aesthetics are assumed to be in the second position. If you omit X here, eruptions, X is assumed to be in the first position here. So you can abbreviate quite a bit, and you need to do fast, extensive data exploration. Exploration can take a long time, and it will have a lot of dead ends. And you have to be alert. And this is something that I have to emphasize. A lot of students are afraid to just drop something and move on to something else. They want some tangible evidence that they were doing exploration. So I often see students including a lot of useless plots in their results. Plots that didn't show anything, but hey, I went to all this effort to make these plots, so I better show them. Don't. You have to be alert to new ideas that appear when you see intermediate results and be willing to change your path. And you have to gain comfort with a tool like ggplot 2 to be able to get into the flow of exploration. Flow is the focused state where you're working comfortably at the limits of your skill and without distraction. In that state, you are most likely to find answers. You must strive to get into that state. And you can read about it. You can read about the concept of flow in the writings of this guy, whose name I can't pronounce. In fact, I can't even spell it. Every time I have to write it, I just Google the word flow. He made the word flow in psychology famous. So his name always shows up if you Google the word flow. And you can read about this concept of flow, and you need to know about it. You need to be, you need to cultivate the talents and skills that will help you get into a state of flow when you're doing data exploration. All right, that's all I have to say about that. Thank you very much for your attention.